Okay, here we go. Last one for the week is calculating areas of sectors and arc lengths. I like to refer to it as the pizza or the crust. So the area is going to be the pizza. You got all the red part. And that ends up being a fraction of the whole. Both of these are just fractions of the whole. For area, it's fraction of pi r squared. And for the circumference or arc length, which is a part of the circumference, remember the circumference all the way around, it's a fraction of 2 pi r. So for degrees, the fraction is how many of the degrees over 360, or for radians, r over 2 pi. And then the same thing over here for the arc length. You have 2 pi r instead of the pi r squared. That's theta. I think this is the first time we're meeting theta. That's the variable you most often associate with angles. X is to sides as theta is to angles. Okay. So I picked a couple of SAT problems to try to make this make sense or show you where it's going to be used. So you got a circle with center O, central angle of AOB. It has a measure of 5 pi or 4 radians. All right, so there's the radians. This is one of the reasons I'm teaching you stuff, so you'll be able to answer this question on the SATs. The area of the sector formed by the angle AOB is what fraction of the area of the circle? Okay, so in case you forgot your area formulas, please remember beginning of SATs. There it is. There are your formulas. So let's see. First, all right, we got radians, so we're using the r over 2 pi. So I put in the measure of the angle, 5 pi over 4, goes in the top, and there's 2 pi. There, the pi's cancel first. So then you're going to get, don't forget that this is really 2 over 1, and don't divide by a fraction, multiply by its reciprocal. So the same thing is 5/4 times 1/2 times pi r squared equals 5/8. Remember, you're just multiplying tops and bottoms. 5/8 pi r squared. So that's the area of the sector. And then you got area of the sector over the area of the whole. And then you please see the pi r squares just cancel each other out, and you're left with 5/8. Okay, so there's one where you're doing area. And now over here, now this one's, both of these are at the end of the SATs. The harder ones are towards the end. So this one requires you to remember a little bit of geometry, but you're using the same formula. To find the measure of ln, we have to take the fraction of the whole. So I need to figure out what this LON angle is. And I got a 60 out here. So they tell me there's tangent. So the thing you got to remember with tangents are perpendicular to the radius. That tangent right there makes a 90-degree angle. Okay, now we go ahead and we draw in that dashed line. I'm not going to make you prove it, but these two triangles are congruent by the hypotenuse leg theorem. So now I know this is the same as this, and therefore this little red dashed line bisects this angle, and this was 60. So that means each one of the angles is going to be 30. And so now if this is a triangle, we know it's going to add up to 180, at least in Euclidean geometry. So I got a 30 here, a 90 here, and 30 and 90 is 120. 60. So this is going to be 60, and that's going to be 60. And if I add 60 and 60, I get 120. So now I know this angle, which I'm going to call D, is equal to 120. Uh-oh, there was supposed to be some stuff there. There's stuff over here. Okay, D is 120, and then it's a 120 over 360. We did that already, 1/3, and 1/3 of 96 is 32. I'm not sure what's supposed to be over there, but I'm going to say that's it for that one. Okay.